Hello, you're welcome to this video, and in this video we are going to be talking about non-linear graphs, otherwise called curves. Well, let me say it in the Nigerian way, curves. So we are talking about curves, which means graphs that are not straight. Just don't think rubbish. Okay, all right, now let's come back to this one. All right, so when we talk about curves, we mean graphs that are not straight, okay? Like the line is not straight. It's not like a straight line graph, but like it's having some kind of slope somehow. Like, okay, if I have something like this is a curve, okay? If I have something like this is a curve. If I have something like this, it's a curve. Okay, in as much as the graph is not linear, like in as much as it's not sharply straight, okay, either upward or downwards, then that kind of graph is regarded to as a curve. Okay, now, but then, you know, we had, in the previous video, we talked about the equation of a straight line. We talked about lines having like, okay, y equals to mx plus c. But in the case of curves, there is nothing of such, which simply means we don't have a specific equation of a curve. The only thing about it is that we have some kind of characteristics that help us to recognize curves. Okay, that immediately the moment you see the equation, you know that, bam, this one is not a straight line equation, it's not a linear equation. Well, what determines principally whether an equation is linear or not linear, okay, a major determinant is the coefficient of x, is the x itself. The coefficient is the slope for a straight line graph. But then what really determines whether a line is a curve or not is the situation of that x. So if I have something like this, for instance, y is equal to 3x minus 5. It is very easy for you to say this is a linear equation. Why? Because x itself, the power of x is 1. It's not carrying any power. And, you know, it's just okay. It's just sharp. Another thing, again, for you to determine that it's a straight line equation is that y itself has a power of 1. So which means that for every value of x, you can only have one sharp value of what? Of y. But a situation whereby you can have two possible values of y, or more than one possible values of y for a given value of x, like the way you have in a quadratic equation, where x, you say x is equal to -1 or x equals to 5, you know, and all of that. So, but when the moment you're having a situation whereby you can have more than one possible value for y, value of y for a corresponding value of x, then it means that that graph is definitely not a linear graph. It's definitely not going to be a linear graph. Okay, so which means another thing is if I have something like this, y squared is equal to 3x minus 5. Even despite the fact that the coefficient of x, that x here carries no power, the fact that y raised to power 2 is equal to 3x minus 5, not ordinary y, this graph can never be a straight line. Okay, in a nutshell, we are going to be having something like this, y equals to the square root of 3x minus 5, and then, you know, by the time you plot this graph, you are definitely not going to have a straight line graph, a straight line. You understand it now? So, for you to have a straight line graph or a linear graph, you need to have this thing happening like this, sharp, which means x will carry no power, y will carry no power. Then you are going to have a straight line graph. So, anything apart from that is most likely going to be giving you a curve. Most likely going to be giving you a curve, especially when you cannot reduce it to something of this form mathematically. Do you understand it now? So, yeah, that's it. Okay, another way you can know, if I have something like this, for instance, y is equal to 1 over x, okay, plus 5. This one too is never going to be a straight line graph because of the fact that this 1 over x can also be regarded as y equals to what? X raised to power minus 1 plus 5, according to law of indices. So if this is like 1x squared, then it can be 1 x raised to power minus 2. If this is 1 all over x cubed, then this one will be what? X raised to power minus 3. Okay? The moment it carries a power, okay, okay, then it can never be a straight line graph. Okay, so that's that aspect. So you can recognize a nonlinear graph using a couple of factors, but there is no specific equation, okay, for a nonlinear graph the way we have a specific equation format for a linear graph. Just take note of that. All right, so we come back to this. Now, another thing again about nonlinear graph is that the slope of a nonlinear graph is not the same, unlike the way we had it for a linear graph, that anywhere you choose the point from, you're always going to get the same answer. But for a nonlinear graph, the slope at this point is different from the slope here, is different from the slope here, is different from the slope here, is different from the slope here. The slope is different at every point across the graph. Okay? So that is another property of a nonlinear graph. We have different slope at different points across the graph. So now, how do we now find the slope? That is the reason why whenever you have a situation like this, the question can only ask you to find the slope of the graph at a specific point, which means they will specify a value for x for a value of x for you to find the slope at that point. For instance, the question can say, okay, find the slope of the graph at point x equals to -2. So the question has already specified that point x, which is equal to -2, find the slope of the graph at that point, period. So what you do in that case is locate the point and you draw a straight line. Draw a straight line, which in such a way that it will not break into the graph. Okay, when I say break into the graph, if for instance you are meant to find the slope at this point, so the solution to find the slope is that because I want to find the slope at this point, I'm going to draw a straight line that will touch the graph only at that point. A straight line that will kiss the graph only at the specified point. So you are going to be so careful about positioning your ruler when you are going to be doing something like that. Okay, so you make sure that the graph is only the straight line you draw to find the tangent, the slope at that point, touches the graph only at that point. This straight line that you draw in order to find the slope at a particular point is called the tangent. It's called a tangent line. All right, so it's called a tangent line. Now, if I make a mistake by drawing maybe I want to find the slope around this area, this point, for instance. You know, if I draw this line here, this is going to be a tangent line. Sorry, I'm just trying to make sure that it touches the graph only at that point. So this is going to be a tangent line. But if I draw a line like this, and or maybe by mistake this line enters into the curve, okay, if I draw it that way, then it means that this one is no longer, this line here is no longer a tangent line. Rather, it is called a secant. S-E-C-A-N-T. It's rather called a secant when the straight line cuts into the curve. But a straight line that only touches the curve at a specific point, that straight line is called tangent. And it is the tangent line that we actually use to find the slope of the graph at that point. And so this takes us back to the graph of a straight line. We are going to find the slope of this tangent using the normal way of finding slopes, which means try to extend the line as much as you can and try to pick any 2 points across the line, the same way you did for in trying to find the gradient of a straight line. We are going to find the gradient of this tangent now, okay, using the value, using change in y over what? Change in x for the tangent line. Pick any 2 points. Find the value of x and y here, and the value of x and y here, okay? Pick the value of x and y at these 2 points, and then find the slope the same way you would have done, y2 minus y1 over x2 minus what? x1, and then get the value. The moment you get the value, any answer you get for the slope of the graph at this particular point, any result you get for the slope of the graph at this point, it automatically tells you Any result you get for this slope of the tangent automatically gives you the result for the slope of the graph at that specified point. Let me repeat. The question may ask you, given a curve, the question may ask you to find the slope of the graph at a specific point. Let's say in this case, at the point where x is -2. All right? So if you have that situation whereby the question says, find the slope of the graph when x is -2, what you do is that at that specific point, draw by yourself, position your ruler in such a way that you draw a line, a straight line that touches the graph only at that point. Then the next stage is to find the gradient of that line. The moment you get the value of the gradient of that line, the result you get gives you the slope of the curve at that particular point. So the ideology is just that, okay, the question you'll be asking me, why must we draw a tangent? Well, a tangent is just like a magnifier. As small as this point is, we can form a straight line at that point. So the tangent is just as if you extended the point, you extended it in a sharp way. That is to say, that particular point, we can, as if you use a microscope to check it, that even despite it's a point, there's still a straight line between an interval across that point. So that straight line is the line that you now do what? You magnified, that you extended. So which means that the tangent line is serving as an extension of the tiny straight line that can be formed at that particular point, a microscopic straight line. Let me put it that way. So that is just what this guy is just trying to show us. And then, you extend it, and then you now find the gradient of that straight line, of that extended line. It tells you the value of the gradient at that particular point, the slope at that point. So that is just what it means. And remember, the same law that applies to the slope of a straight line applies to these tangents too, which means you can pick any point, you're still going to get the same results all through. But whatever is it that you got for it determines the gradient or the slope of the curve at that particular point. So when it comes to curves, we hardly use the word gradient. We use slope, okay? All right, so some people will specifically use gradient for straight line and use slope for curves, but both of them mean the same thing anyway, okay? So that is that, as for that. All right, well, let's just quickly delve into some properties of the slope of a curve, or the properties of a curve, some other properties of a curve, apart from the fact that you can find the slope using a tangent. So these properties are very important because there are some questions that are set based on those properties. So don't just look at it that, okay, you're just wasting your time learning this thing. Apart from the knowledge you're gaining from it, you should also know that you are preparing for your exam, and all those properties, there are some questions set stylishly to seek your knowledge or to demand your knowledge of those properties, and then so you need to just keep them at the back of your mind. Right, so let's check out property number 1. What happens if I have a U-shaped curve? I have a U-shaped curve. What happens if I have a U-shaped curve in such a way that, okay, let me just put it this way. A U-shaped curve in such a way that I need to find the slope of the graph at this minimum point of that curve, at this lowest point of the curve, okay? That U-shape, the center of it. So if I draw the slope, if I draw the tangent, okay, you should take note of 2 things. Note number 1, although you can have 2 different values of x, like let's say this is x1, and another value of x, let's say x2, across that straight line. But this line happens to be parallel, which means here the tangent is what? Is parallel to the x-axis. When the tangent is parallel to the x-axis, what happens? It means that this is the x-axis, this is the tangent, the 2 of them are parallel, totally parallel. No matter how you extend the line, they will never meet, they will never join. So they are parallel lines. So what happens in that case? The tangent is parallel to the x-axis. So what happens? You will see that we have only one possible value of what? Of y. We cannot even call it y1 or y2. Y is just the same thing, okay, at that point, regardless of how long the line is, because the line we can only get only one value of y, okay, for that particular line, but we can get different values of x because it's parallel to the x-axis. You can trace different value down to the x, but only one value for the y because of the fact that it is parallel to the x-axis. I believe you understand what I'm trying to explain. It's practical. So what happens in this kind of case? If you want to find a slope, you say slope is equal to what? Change in y over change in x, right? Now the point is that the value of y at the initial stage still remains the value of y at the final stage. So y did not change. In that case, the change in y is what? Is 0. Okay, which means in real life, you can have the value of x here as 1, the value of x here as 10. So x changed actually, all right? But the value of y changed? No, maybe the value of y here is safe at this point. Let's say y is 5 at this point. It is still going to be the same 5, even at the second point, or at the fourth point, at the fifth point, at the sixth point. It's going to be the same value of y as 5, okay? Nothing is changing for y. So which means the change in y is 0, but the change in x has a value, okay? There is a value. Let's say x is 10 here, 1 here. That's going to be 9. But 0 divided by anything in mathematics, the answer is what? 0. Is 0 divided by anything, the answer is 0. So what is the lesson that we learned here? The lesson learned here is that regardless the slope of when the tangent is parallel to the x-axis, the slope is always equal to 0. When the tangent is parallel to the x-axis, okay, you see that what? The slope is equal to what? Always equal to 0 when the tangent is parallel to the x-axis. All right, so let's consider another case, a case whereby the tangent is parallel to the y-axis. What happens when a straight line is parallel to the y-axis? Be it a tangent or an ordinary straight line, what happens? So let's say we have a situation, let's say we have a C-shaped graph, and then the question says find the slope at this particular point here, okay? So if you draw a tangent, clearly the tangent is going to be a line that is parallel to the y-axis. So if you trace the value of the line down to x, you have a single value of x, all right? You have a single value of x, but you can have different values of y across different points of the line, okay? You can have different values of y across different points of the line. So let's say this is a particular value of y, y0, or y, let's say y1, and another particular value of y, let's say y2, okay? Then the distance between the y2 and y1 gives you the change in what? In y, no problem, but we do not have any change in x. In this kind of case, if you want to solve this question, so what you do, okay, you say the slope is equal to change in y over change in x normally. Yes, change in y exists, but change in x does not exist because x has only one value. So x2 minus x1 is 0 because the same value. If x was 3 here, then it means 3 minus 3 will be 0 because it's still the same value. Whether I choose my y, if my y is something here, my x remain 3. If my y is anything here, my x still remains 3. If my y is anything here at y2, the x still remains the same value, 3. I'm just assuming a value for x. So which means change in x is nothing. Change in x is 0. So in this case now, that is a case whereby we have the line parallel to the y-axis. What happens in that case? It means that slope is going to be equal to what? Infinity. Slope is infinity because anything divided by 0 is infinity. Or you can say undefined. Undefined. So no value, no answer, no answer for it. Anything divided by 0 in mathematics is what? Is undefined. Or you can say it is infinity. All right, so which means that another property we need to take note of is that if the tangent line or any given straight line is parallel to a y-axis, the slope of such a line is always undefined. You get that? So please take notes. So we've talked about the positive slope, we talked about the negative slope, we talked about the zero slope, and we talked about the undefined slope. So these are different conditions of slopes that we can have depending on the situation of the tangent line or on a given straight line. Do you understand? And there is something again I just still want to tell you about. Well, I don't know if this is important, but the y-axis, that is any line that goes arbitrarily vertical, any arbitrary vertical line or any line that is just totally vertical, okay, is called an ordinate. Ordinate. While the one horizontal is called the abscissa. Abscissa. Okay, sorry. Abscissa. So this is the ordinate, and then this is called the abscissa. Okay, so that's the y-axis, the x-axis, or any straight vertical line and horizontal and all that. So, all right, so that's just that as per that. So I've told you about the straight line graphs, about nonlinear graph, the fact that there are lines that are curvy in nature. Then I've told you also that their slope is always different at different points across the line. I also told you that to find the slope of any curve, you need to just draw a tangent line at a specific point, okay? Because you can only find the slope at a specified point. You cannot have a general slope for a curve, okay? And then I also told you again that the name of that line is called a tangent line. And then we also talked about what happens when the tangent or any straight line is parallel to the y-axis, and what happens when it is parallel to the x-axis and the conditions, okay? And so these are just a few things that this video is meant for. So in the next video, we'll just talk about how we can apply this, being to explore how we can apply this to physics, okay? Then, meet you there. Bye.